Now we are going to study question 7 from chapter 4, that is December 2014 exam question 2. This question we are going to study. So everyone, first of all, before going further, give the heading of the question number 7, December 2014 exam question 2. Everyone, first of all, give the heading of the question. Give this heading, question 7, December 2014 exam question 2. Now, after giving the heading, try to read this question minimum 2 times. Everyone, after giving this heading of the question, try to read this question minimum 2 times. Minimum 2 times. You can read as much as time you want. So first of all, try to read the question minimum 2 times. Now, after reading this question, we come to know that it is a simple gas turbine plant. After reading this question, what does we come to know that it is a simple gas turbine plant. So in this question, they have not asked us schematic drawing to draw the schematic drawing. Though they have not asked us, but our first task is what in a question of gas turbines, our first task is what to draw the schematic diagram of the gas turbine plant. And here we have what simple gas turbine plant, and by default it is open cycle gas turbine plant. So here see, so this is what our schematic drawing. Let me little bit zoom it. So this is what our simple gas turbine plant. This simple gas turbine plant consists of 3 main components: compressor, turbine, and CC stand for what? Combustion chamber. Here we are getting W net. Here we are giving Q addition. This is a Q addition. Here we have air. So before going further, so here we have air, here we have a gas. So now before going further, what you have to do? Draw this figure properly, guys. And then we will read the question further and try to write down the given things. So everyone, before going further, draw this figure properly. Now I'm going to read the question here carefully. What they are asking us in A part, sketch the cycle on a TS diagram. So our target of A part is what? Sketch the cycle on a TS diagram. We will see, we will draw the A part also. But before that, we will try to read the given things. Now here observe the scenario. Air enters the compressor of a simple gas turbine plant. Observe the things here carefully. Air enters the compressor of a simple gas turbine plant at a pressure and temperature of 1.03 bar and 305 Kelvin. So this pressure will be what? Observe. So this pressure will be what? Our P1 pressure, 0.1 pressure. So air enters to the compressor at a pressure of, so entry to the compressor means what? 0.1. So that is P1 pressure. And this 305 Kelvin will become what? T1. So at the 305 Kelvin, air enters the compressor. So pressure 1.03 bar and temperature 305 Kelvin. With this pressure and temperature, air enters into the compressor, means that are the conditions of the 0.1 entry to the compressor. It is compressed to a 6.18 bar. So this will become what? Pressure of 0.2. So 0.2 is what? Outlet to the compressor with an isentropic efficiency of what? 83%. So now this 83% will be which isentropic efficiency? This 83% will be which isentropic efficiency? It will be the isentropic efficiency of compressor. Now how does we come to know that this will be what? How does we come to know that this is the isentropic efficiency of compressor? How does we come to know that? Because this first paragraph is entirely related with what? Compressor. This entire paragraph, first paragraph, is related with compressor. So by default, this isentropic efficiency they have given us 83% is of compressor. Now try to see the scenario here. Now, so here we have what? P1, T1, P2 and isentropic efficiency of compressor, that is eta C. Now hot gases leaves the combustion chamber. So hot gases, so air enters to the combustion chamber and where combustion will take place, and due to combustion we will get the hot gases, and hot gases leaves the combustion chamber at a pressure of what? 6.18 bar. Just observe here. What is the pressure of point 2? 6.18 bar. What is the pressure of point 3? Outlet to the combustion chamber. Outlet to the combustion chamber is what? Point 3. So pressure of point 3 will be what, guys? 6.18 bar. So here P2 and P3 is what? Same. And at a temperature of 1210 Kelvin. So this 1210 Kelvin will become what? Outlet to the combustion chamber. So this will be what? T3. Turbine exhaust pressure. Turbine exhaust pressure means was outlet to the turbine. That will be our pressure of 0.4. And a temperature of 805 Kelvin. That will be temperature of this is pressure of 0.4 and this is water temperature of 0.4. Now if you observe, just have a look here carefully. What is the pressure of 0.1? 1.03 bar. What is the pressure of 0.4? 1.03 bar. So here if you observe here carefully, pressure of 0.1 and pressure of 0.4 is the same. And second thing means 1 and 4 point pressure is same. And second thing is what? Pressure of 0.2 and pressure of 0.3 is the same. So what we can say? P2 is equal to what we can say? P3. So always remember one thing. In case of the gas turbine question, our target is what? First target is what? Identifying the pressure. And in case of the gas turbine, simple, generally, it is not compulsory that, generally, so generally in case of the gas turbine, there are simple gas turbine plant, there are two pressures. First one is what? P low, and second pressure is what? P high. So what is P low pressure? Point low pressure will be what? 0.1 pressure and 0.4 pressure. 0.1 means what? Entry to the compressor. 0.4 means what? Outlet to the turbine. So P1, let me write down properly. P1 is equal to what we can say? P4, and that will be equal to what, guys? 1.03 bar. 1.03 bar, and 1.03 bar means what? 103 kilonewton per meter square. Now here the next point is what? High pressure. Which point we will have high pressure? 2 and 3. So here pressure of 0.2 and pressure of 0.3 is the same. So P2 and P3 is the same, and they have mentioned P2 and P3 here. Just have a look here. This is what our P2 and this is what our P3. So P2 and P3 is same. So P2 is equal to P3, and that will be what? 6.18 bar. And 6.18 bar means what? 618 kilonewton per meter square. So now here, then we will have what? Temperature of 0.1. What is the temperature of 0.1? T1 is what? 305 Kelvin. Check it, guys. Check it. Always be attentive. So 305 Kelvin. Then hot gases. What thing is remaining from first paragraph before going for the next paragraph? Isentropic efficiency. So that is isentropic efficiency of compressor. We will say eta C. That is 83%. 83% means what? 0.83. Then after that what we have? Hot gases leaves the combustion chamber and enter the turbine at a pressure of 6.18 bar and a temperature of 1210 Kelvin. So here we have already written this P3. Here see P2 and P3 6.18 bar, and that will be what? Now the further this 1210 Kelvin is what? Temperature of point. This 1210 Kelvin is a temperature of 0.3. So here T3 will be equal to what? 1210 Kelvin. Now the next thing is what? Turbine exhaust at a pressure of 1.03 bar. We have already written P4. Just have a look. And 805 Kelvin. So 805 Kelvin will become what? Temperature of 0.4. So 805 Kelvin. Then after that we will have a fuel air ratio, guys. What is meant by fuel air ratio? Fuel air ratio means what? Mass of fuel divided by mass of air. Observe the things here. Mass of fuel divided by what? Mass of air. And mass of fuel divided by mass of air. How much they have given us in the question? 0.0125. So that is the ratio. So that ratio is what? 0.0125. Now then next in the note, always read the entire question carefully. So in the note they have given us gamma of air, Cp of air. Gamma of air, how much they have given us? 1.4. Cp of air 1.005 kilojoule per kg. So here before going further, first of all I am writing gamma of air. Gamma of air 1.4 and Cp of air. Cp of air means what? Specific heat of air 1.005 kilojoule per kg Kelvin. Then we have what? Gamma of gas. Next sentence guys, observe here. Gamma of gas, hot gas 1.33 and Cp of gas is what? 1.15 kilojoule per kg. So I am going to write down gamma of gas is what? 1.33 and then we will have what? Cp of gas 1.15 kilojoule per kg Kelvin. So these are the given things to us. Observe the things here carefully. So before going further, everyone, guys, please write down all these given things, starting from P low, P high, T1, eta C, and try to understand the meaning of each and every term, guys. Don't write down blindly. So please everyone write down this discussion. Now after writing down these given things, what is our first target in A part? In A part what they are asking us, sketch the cycle on a temperature specific entropy diagram. So we have to draw the what? In A part our target is what? We have to draw the TS diagram. So what is our target in A part? We have to draw the TS diagram. We discussed this point in our theory. But still for the revision purpose I am drawing once again. We discussed thoroughly in our theory of this chapter, but still we are discussing this one so that you will get a more clarity on how to draw the TS diagram, guys. Observe here how I am going to draw. First of all I am going to draw the axis of the temperature and entropy. So this is what our temperature T and this is what our entropy S. Now the next thing is what? Always draw the two pressure lines here. This is a simple gas turbine plant. So here we will have our two pressure line. First pressure line is what? P low pressure line. So here this pressure line is what? P low pressure line, we will say. So this is what? Our P low. After that we will draw what? High pressure line. This high pressure line is what, guys? P high. So here we will have what? Two pressure line. First one is what? P low. So this is what? Our P low. And second pressure line is what? P high. So here our first target. First we have drawn TS, axis of T and axis of S. Then we have drawn two pressure line, P low and P high. Then ideally what is process 1 to 2? Ideally process 1 to 2 will be what? Isentropic. So here I am going to draw one straight vertical line. Observe the things here carefully. Ideally process 1 to 2 is what? Isentropic. So point 1 is on low pressure line, that is P1. Point 1 is so pressure of point 1 P1. So here we will have a point 1 and ideally so straight vertical line means what? 1 to 2i and that will become what? S1 is equal to S2i and I am going to make it as a what? A dotted. Observe the things here carefully. Very simple discussion, not that much difficult discussion. So 1 to 2i ideally will be what? So this 1 to 2i ideally will be what? Isentropic. Now then next, actually non-isentropic compression. So 1 to 2 will be what? Actually 1 to 2 will be what? Non-isentropic compression. So here we will have what? 1 to 2 will be what, guys? Non-isentropic compression. Then 2 to 3 will be what, guys? 2 to 3 will be what? Constant pressure heat addition. So we will follow this line. 2 to 3. 2 to 3 will be what? Constant pressure heat addition. And what we are going to do? We are going to make the remaining curve, this high pressure line dotted. Just observe the things. The remaining one, what we are going to do? We are going to make it as a what? Dotted. And here we will have what? 1 minute, let me make it little bit dark. So this will be what? 2 to 3. Our 2 to 3 will be follow this high pressure line. Then next thing is what? 3 to 4i. Ideally 3 to 4 will be what? Isentropic. So we will say 3 to 4i isentropic expansion in the turbine. So 3 to 4i ideally. So here we will draw a straight vertical line. Observe the things here carefully. Understanding these concepts are very, very important. Then you have to memorize less things here. So here we will have what, guys? I'm going to make it as a what? A dotted straight vertical line. And here this will be what? Our point 4i. And here we will say S3 is equal to S4i. And then 3 to 4 will be what? What will be the 3 to 4? Non-isentropic expansion. So this is what our TS diagram of this question. And what we are going to do? We are going to make this low pressure line. What we are going to do? We are going to make this low pressure line a dotted. Observe the things here carefully. Very simple discussion. Very, very well. So now guys, before going further, try to draw this TS diagram properly. Use different color pens so that your notes must be in proper format. And try to draw the things properly. Try to see the meaning of each and every word. Here I have missed arrows. Never miss the arrows, guys. These arrows are very, very important. These arrows gives us how the process are going on. Oh, here we are going from 1 to 2, then 2 to 3, and then 3 to 4. So always never miss the arrows, guys. So please everyone, before going further, please draw this TS diagram, guys. This is A part answer. Now after TS diagram, what is our target in B's first part? After TS diagram, what is our target in B's first part? What we have to calculate? Isentropic efficiency of the turbine. What is our target, guys? What we have to calculate? Isentropic efficiency of turbine. Let me first of all erase all these things so that you should not get confused with all these points. So what is our first target in B's first part? Next target, guys, isentropic efficiency of the turbine. That is what we have to calculate. And how to calculate isentropic efficiency of a turbine, guys? Observe the scenario. So B's first part target is what? Isentropic efficiency of turbine. So what is the relation of isentropic efficiency of turbine? We have seen, if you remember our discussion. See, what is the relation? What we will say? T3. Just go through your theory. We have seen that relation, guys. So T3 minus T4 divided by what? 1 minute. T3 minus T4 divided by what? T3 minus T4i. So this is the relation of the isentropic efficiency of the turbine. That is what our target in B's first part. Isentropic efficiency of the turbine. And what is unknown here? If you want isentropic efficiency of turbine, what is unknown here, guys? We have what? If you see the given things, we have a T3, we have a T4. So just only one thing is unknown in this relation. That is what? A T4i. This thing is unknown to us. And how to get that T4i, guys? Observe the scenario. So we have seen relation for process 3 to 4i. We have seen this relation in our theory. So what is process 3 to 4i, guys? Isentropic process. What is process 3 to 4i? Isentropic. And what is the relation for that isentropic process? T4i by T3 is equal to what? P4i divided by P3 raised to the power gamma minus 1 by gamma. And here remember P4i is equal to what? P4. See, 0.4i and 0.4 is on the same pressure line. So what we can say at the end? T4i will be equal to what? T3 into P4 by P3. Observe the things here carefully. Try to see the meaning of each and every term. P4 by P3 raised to the power gamma minus 1 by gamma. And here which gamma we have to take? Gamma of gas. Why? Because in 3 to 4 process, what is there in the turbine? We have a gas in the turbine. Guys, observe the things here carefully. So now what we are going to do? We are going to see T4i. So what is the value of T3 they have given us in the question? See the value of T3, 1210, 1210, P4 1.03 bar, na? Check it. P4 1.03 bar means 103. Then we will have what? P3 618 kilonewton per meter square. Check it guys, in the given things we have written gamma minus 1 for the gas 0.33, gamma is what? 1.33, and if you do the calculation then we will get a value of T4i. So now guys, everyone try to do the calculation with me. 1210 multiplied by what guys? In bracket 103 divided by what? 618 raised to the power 0.33 divided by 1.33. So we will get a what? What is the T4i? T4i will be what? 775.7294 unit Kelvin. So we got it what? T4i. And then with the help of T4i, we will going to calculate isentropic efficiency of turbine. And what is that relation we have seen? What is the relation that we have seen? T3 minus T4 divided by what? T3 minus T4i. I'm going to put the all values. What is the value of T3? 1210. T4, 1 minute, check. Let me check. What is the value of T4? 805 Kelvin. 805 Kelvin. T3 1210. T4, 1 minute guys, I have done some. What is the mistake I have done in this relation? What is the mistake I have done here in this relation? Here it must be what guys? T4i, and T4i will be what? 775.7294. So everyone do the calculation and try to find out the isentropic efficiency of the turbine. Try to put these things directly into the calculator guys. 1210 minus 805 divided by what? 1210 minus 775.7294. So if you see the what is the value of isentropic efficiency of turbine we are getting? 0.93. 1 minute guys. 0.9326. It means what? 93.26%. So in this way, what we got it guys? Isentropic efficiency of the turbine. That is what. 1 minute. Let me make it the answers. Always make the answer in box guys. It is a good practice. So in this way we got it what? B's first part answer. So now guys, before going further, what you have to do? Before going further, write down all this discussion up to T4i guys. First of all, everyone, before going further, write down this discussion up to T4i. After writing down this discussion, what you have to do guys? Then write down the next point guys. Everyone, write down this next discussion. So now after this one, what is our next target guys? In B second part, net work output per kg of exhaust gas. Guys, see the point here. Per kg of exhaust gas. What is our next point? Per net work output, we have to find out W net. W net for what? How much mass of gas? Per kg of exhaust gas. So mass of gas will become what? 1 kg guys. This point is very, very important. And here we can't neglect mass of fuel. And why we can't neglect mass of fuel here? Because they have given us here fuel air ratio. In few questions guys, if you go through some questions, in that mass of gas and mass of air, we have to take the same. We have to neglect mass of the fuel. But here in this scenario, mass of fuel air ratio is given. Guys, in this question, fuel air ratio is given. So we can't neglect mass of the fuel, guys. So here mass of gas and mass of air, both are the different things here. Only little difference is there, but still we can't neglect here. So now what is our target here, guys? In which second part, what we have to find out, guys? In which second part, what we have to find out? In which second part, what is our target, guys? We have to find out W net, work output per kg of exhaust gas. So what is our target? First of all, I will write down the target. So what is our target? What we have to find out? W net. And if you remember our relation of the W net, what we have seen, W net means what? Turbine work minus compressor work. And how much mass of gas they have given us in the question? If you see, how much mass of the gas they have given us in the question? Mass of the gas they have given us is what? 1 kg. Means per kg of exhaust gas. So here we have what? Mass of gas is what, guys? 1 kg. Try to see the scenario. Now, so here, before going further, guys, what we are going to do? What we are going to do? So we need a what? Turbine work. To get a W net, we need a what? Turbine work, and we need a what? Compressor work. So first of all, we will try to calculate what, guys? Turbine work. And what is the relation of turbine work, guys? What is the relation we have seen? Wt will be equal to what? M gas, Cp gas, specific heat of gas, into what? Higher temperature, that is at the entry to the turbine, minus what? T4, guys. So always remember here. And mass of gas is what? 1 kg. Cp of gas is what? 1.15. And T3 is how much, guys? T3, how much they have given us here? We have written. So 1210. T4 they have given us is what, guys? How much T4 they have given us? 805 Kelvin. 805 Kelvin. So here we will have what? Wt. So guys, before going further, please everyone calculate these things. So what is the answer everyone getting? That Wt will be what? 465.75 kilojoule, and this is on the basis of per kg of what, guys? Per kg of exhaust gas. So here, so before going further, guys, please everyone write down this discussion up to this Wt. Now, so we got it Wt. Now to get a W net, what we need, next thing we need a what? Compressor work, that is Wc. And what is the relation of Wc we have seen? Mass of air into what? Specific heat of air into what? T2 minus T1. We have seen this relation, completely we studied. Now what we need here? First of all, we need a mass of air, and second thing we need a what? T2. These two things are unknown in this relation. Remaining things we have, guys, T1 also we have, specific heat of air also we have. So first of all, what is our target? What is our target, guys? We have to find out W net. For W net, we need a Wt and Wc. Wt just now we calculated, and what we need now, next thing, Wc. And to get the Wc, which things are unknown in this equation? Mass of air and T2. And how to get the mass of air, guys? We will see this. For that purpose, we will use this relation. Mass of gas is what? What we studied? Mass of air plus what? Mass of fuel. We studied gas consists of what? How we get exhaust gas, guys? After the burning of the air and fuel, so mass of air will combine with mass of fuel and we will get the gas. So here, now try to see the scenario. One thing they have given us in the question, what, guys? Mass of fuel divided air fuel ratio they have given us, divided by mass of air, that will be what? 0.0125 they have given us. So what we can say further? Mass of gas will be equal to what, guys? Mass of air plus mass of fuel will become what? With the help of this relation, 0.0125 into what? Mass of fuel. Now if you combine this relation, so what we will become what, guys? Basic mathematics 1 point. So here if nothing is there, it means what will be the coefficient here? 1. So 1 plus 0.0125, so 1.0125. 1 minute, guys, I have made a mistake here. It must be mass of air. So mass of air. Now the next thing will be what will be the mass of air? Will become what, guys? Mass of gas divided by what? 1.0125. and mass of gas, how much they have given us? 1, divided by it will become 1.0125. and how much mass of air we will get, guys? 1 divided by what? 1 divided by 1.0125. so if you do the calculation, how much mass of air we are getting? 0.9877 kilogram. So this is what our mass of air we are getting. So now, guys, before going further, what you have to do? So before going further, everyone, so we have written up to WT. After that, write down up to this mass of air, guys. Now to get a WC, what we need? T2. And to get a T2, what we are going to do? First of all, we are going to calculate T2I. What we are going to do? First of all, to get a T2, we are going to calculate T2I. And what will be the relation for T2I? T2I will be equal to T1 P2 by P1 raised to the power gamma minus 1 by gamma. And which gamma will be here? Gamma of air, guys. So I am going to put the all values. T2I is equal to T1. How much value of T1 we have, guys? Everyone, see the given things. I am writing down here 305 directly. P2 is how much? 618. P1 103. Gamma is what? Gamma minus 1. Gamma of air is what? 1.4. So gamma minus 1, 0.4 divided by 1.4. So do the calculation, guys, and tell me the value of T2I. So everyone, so 305 in bracket 618 divided by 103 raised to the power 0.4 divided by 1.4. So always do the calculation with me, guys. So 508.89 8957 Kelvin. So we got it what? We got the value of T2I. So before going further, please everyone write down this discussion up to T2I. Now after writing down this discussion of T2I, next point will be what? Isentropic efficiency of compressor. And what is that relation we have seen? T2I minus T1 divided by what, guys? T2 minus T1. And what is the isentropic efficiency of compressor we have, guys? We have isentropic efficiency of compressor 0.83, T2I 508.8957, T1 305. And what is unknown here, guys? T2 and T1 305. If you solve this equation, guys, we will get the value of T2. So everyone, please try to solve this relation. So 0.83. Everyone try to solve this one and try to get the value of T2. So after solving this relation, we will get a value of T2 will be what, guys? 550.6575 Kelvin. So what we got it? We got the value of T2. So everyone, before going further, please everyone write down this discussion up to T2. Now after getting T2 guys, what we are going to do? So why we calculated T2? Why we calculated T2? We need a what? WC. And why we need a WC? To get a W net guys. And don't forget the target. Our target is what? To get the network output, and that will be WT minus WC. We already got the WT. We need a what? A WC, and to get a WC we need a mass of air and T2. Mass of air we calculated guys. How much we calculated? 0.9877. And now we just now calculate T2 also. Now we can easily calculate what? A WC. So WC will be what? Mass of air into what? Specific heat of air into what? T2 minus T1. Mass of air, how much we calculated guys? 0.98. Check it. 0.9877. Just now we calculated few minutes before. Cp of air 1.005. T2 is what? Here we calculated guys. T2 550.6575 minus T1. So how much T1 they have given us? 305. So please everyone do the calculation and tell me the value of compressor work. So 0.9877 multiplied by 1.005 into 550.6575 minus 305, 243. So how much guys, everyone, how much compressor work we are getting? 243.849 kilojoule per kg of exhaust gas guys. This discussion is on the basis of what? Per kg of what? This discussion is on the basis of what? Per kg of exhaust gas guys. So this discussion of the WC is on the basis of what? Per kg. So this compressor work, when exhaust gas is 1 kg, this will be the mass of air, and for that purpose how much compressor work we have to do. So that's why, so here we got it WC. So before going further, please everyone write down this discussion up to WC. Now what is our target here? We have to find out net work per kg. So W net will be equal to what guys? WT minus WC. So how much turbine work we calculated guys per kg basis? 465.75. So how much turbine work we calculated guys? 465.75. Let me check it once again. 465.75 minus compressor work per kg of exhaust gas 243.849. And if you do the calculation guys, we will get a what? W net. So everyone do the calculation with me. 465.75 minus 243.849, and we will get a what? W net 221.901 kilojoule per kg of exhaust gas guys. This entire discussion on the basis of what? Per kg of exhaust gas. So in this way we got the answer of what? B's second part. Very simple discussion guys, not that much difficult discussion. So we have already written up to WC. So now guys, write down the next point, this W net discussion guys. Please everyone write down this discussion of the W net. Now what is our next target guys? What they are asking us in B's third part, thermal efficiency of the cycle. What is our next target? What we have to find out? Thermal efficiency. Very simple point, thermal efficiency of the cycle. And how to get the thermal efficiency of the cycle? That is also very simple point, how to get the thermal efficiency of the cycle. So in B's third part, our target is what? What we have to find out? Eta TH, that is what our target. And what is the relation of eta TH guys? We have seen W net output, that is network output, divided by what is input that we are giving? Heat addition, W net by Q addition. And what is unknown here? Q addition. And how to get a Q addition, guys? Very simple relation. Q addition will be what? Mass of gas into what? Specific heat of gas into what? T3 minus T2. See this one. See this drawing. From that drawing, from this schematic drawing, we will get a more clear-cut idea, guys. 2 to 3 is a what? Combustion chamber, and here we are adding the his. So T3 minus T2, and what is there in combustion chamber? Gas, guys. You will say, sir, air here, gas is here, but at the end net combination is what? A gas. So here we are writing in this relation, we are writing gas, guys. So now mass of gas, how much they have given us? 1 kg. Cp of gas 1.15. Check it, guys, how much Cp of gas we have in the given things. Cp of gas 1.15 kilojoule per kg K. Then we have what, guys? Next T3, how much T3 they have given us? Check it, guys. 1210. T2, how much we calculated? Here we calculate T2 550 65 75 65 75 550.65 75. Check it, guys. 1210 550 6575. Now then, so here we will get the value of Q addition. So please everyone do the calculation with me and try to get the value of Q addition. So 1 into 1.15 into in bracket 1210 minus 550.6575 bracket complete, and we will get a what, guys? Here Q addition 758.2438 kilojoule per kg of exhaust gas, guys. So here we got it what? Here what we got it, guys? Here we got it heat addition. And what is the relation of thermal efficiency? Output by input. So output is what? W net, network output. And how much input we are giving? Heat addition, that is heat supplied to the combustion chamber. And W net is what, guys? How much we calculated W net, guys? Just now we calculated few minutes before. 221.901. 221.901. Q addition is what? 758.2434. And how much thermal efficiency we are getting, guys? So try to see the scenario, how much thermal efficiency we are getting. So 221.901 divided by what? 758.2434. So thermal efficiency we are getting 0.2926. So that will be what? 29.26%, guys. So in this way, what we got it? We got the thermal efficiency. So now, guys, before going further, what you have to do? You have to write down all this discussion, guys. Let me a little bit zoom out so that all things are visible to you at a glance. So now, guys, before going further, please write down all this discussion.